Good morning. Mathematics and Statistics 12th Science Part 2. First topic, differentiation. Basic concepts, formulae, first ddx of x raised to n x raised to n minus 1. Suppose, for example, ddx of x raised to 6, n is equal to 6, put in this formula, so it is equal to 6, n is equal to 6, so 6 x raised to n minus 1, that is 6 minus 1, which is 5. So derivative of x raised to 6 is 6x raised to 5. Second, ddx of root x 1 upon 2 root x ddx of 1 upon x minus 1 upon x square ddx of log x 1 upon x. ddx of sin x cos x ddx of cos x minus sin x ddx of sec x sec x into tan x ddx of cosec x minus cosec x cot x. ddx of tan x sec square x dx of cot x minus cosec square x dx of e raised to x ddx of a raised to x log a ddx of x is equal to 1 ddx of constant c is equal to 0 ddx of y is equal to dy by dx ddx of dy by dx d2y by dx square. Always remember this. ddx of y is dy by dx. ddx of dy by dx is equal to d2y by dx square. Next, ddx of 2 sin x is equal to 2 take outside ddx of sin x is equal to 2 derivative of sin x is cos x. So when there is function, a constant and function, and we have to take derivative at that time, just only take constant and derivative of function. Remember this. When there is constant and function, take constant as it is and take function's derivative. So this is the one trick. Remember this. Suppose ddx of 4x raised to 6. In this case also there is constant and function. So constant take outside ddx of x raised to 6. So 4 into derivative of this is according to x raised to n formula. So 6 x raised to 5. So here is product 24 x raised to 5. That means in such case always remember take product of these two and here decrease this index by 1. So when derivative of such types of functions we have to take, so at that time take product of these two and decrease this index by 1 in this way. Next, ddx of log x to the base a is equal to 1 upon a log x. 1 upon x log a. Log x 1 upon log a. So 1 has सोडवूया आपण काय हा इथे जरा प्रॉपर d dx of log x to the base a is equal to d dx of log x upon log a. Here log rules. According to logarithmic rules, we have write this as log x upon log a. Now 1 upon log a is constant outside and derivative of log x is 1 upon x. So this is in the numerator there is product 1 and here is x log a. So remember this formula, d dx of log x to the base a is equal to 1 upon x log a. Next, rules of differentiation. Rules of differentiation. First is derivative of sum. Derivative of sum. If y is equal to u plus v, then dy by dx is equal to du by dx plus dv by dx. If there are two functions and if there is sum, then take their derivative and take sum. For example, five cos x plus log x. 5 cos x plus log x. First take y is equal to 5 cos x plus log x. Then take derivative of this term and derivative of this term and take their sum. So dy by dx is equal to, according to our rule, constant 5 as it is. We have to take derivative of this term. Now constant as it is, take derivative of this term. Cos x derivative is minus sin x, so minus sin x here. So derivative of this term 5 as it is, derivative of this function cos x is minus sin x plus derivative of log x is 1 upon x. So this is the final answer, minus 5 sin x plus 1 upon x. Then second is derivative of difference. If you have y is equal to u minus v, that means there is one function and there is difference of two functions and we have to take derivative at that time. Dy by dx is equal to, take derivative of first function du by dx minus derivative of this is dv by dx. Suppose for example 1 upon x minus 3 tan x. This one function is given and we have to find derivative of this. So write this as y is equal to 1 upon x minus 3 tan x and take respective derivatives and take their difference. So dy by dx is equal to derivative of 1 upon x is minus 1 upon x square minus sign as it is, constant into function, right, constant as it is, derivative of function tan x is sec square x, and this is the final answer. No chance to next simplification. So this is the final answer. Minus 1 upon x square minus 3 square x. Next is third, derivative of product. If you have function y is equal to u into v, that means there are two functions and there is product and we have to take derivative. So there is rule dy by dx is equal to, write u as it is, take derivative of v which is dv by dx plus v as it is, take derivative of u du by dx. For example, if we have to take 4x raised to 6, 3 raised to x, this is the question and we have to find derivative of this function. Now if we see, then here there are two functions in the product form. First we have to write y is equal to 4x raised to 6 into 3 raised to x, and then y is in the form of product of two functions, so take derivative dy by dx is equal to first function as it is, derivative of second 3 raised to x, derivative is 3 raised to x log 3 plus 3 raised to x, that means second function as it is, derivative of first according to our rule, take here product 24 x raised to decrease this by 1, so x raised to 5. Next simplification step. Next simplification, see what are common. Common we take 4, 3 raised to x, these are the common terms we have to take. X raised to 5 also we take common. So common is 4, x raised to 5 and common is 3 raised to x. What are the remaining terms? 4x raised to 5 common, so here is x. This term is common, so log 3. And here is common this term, here common 4, so 6, and sign is plus. 3 raised to x common, 4 common, so 6, x raised to 5 common, and this is the final answer. Dy by dx is equal to, check this one, 4x raised to 5, 3 raised to x in bracket x log 3 plus 6. This is the answer. Next is rule of differentiation, which is derivative of quotient. Quotient. Quotient, Q-O-T-I-E-N-T. Derivative of quotient if we have function y is equal to u upon v, y is equal to u upon v, and we have to take derivative. So dy by dx is equal to, write v first, v, take derivative of u, du by dx, take minus sign, don't forget, then take derivative of v as it is derivative of u, write u as it is derivative of v is dv by dx upon v square. This is very important quotient rule for derivative. So see once again, y is equal to u upon v, dy by dx is equal to, write v, take derivative of u, du by dx, take minus sign, then u as it is derivative of v is dv by dx upon v square. For example, log x upon 1 upon x, this is function we have to given. Write this as y is equal to log x upon 1 upon x. In this case, this log x is u, 1 upon x is v. So use rule, dy by dx is equal to v as it is derivative of u, log x, derivative is 1 upon x, take minus sign, log x as it is derivative of 1 upon x is minus 1 upon x square. Here is v square, so 1 upon x bracket square is equal to 1 upon, now this term product is there, so product at numerator 1, product at denominator is x square, minus product becomes plus, log x 1 upon x square upon 1 square is 1, x square is x square, is equal to 1 upon x square in the numerator, common, here 1 plus log x 1 upon x square. Steps of simplification. Now in the numerator 1 upon x square, in the denominator 1 upon x square get cancelled. So final answer is 1 plus log x. Derivative of composite function. Sin x, for example, sin x is simple function, e raised to x is also simple function, but when we take sin log x, this is composite function. Suppose we take e raised to root x, then this is composite function. Once again, concept of composite function. Sin x, e raised to x, these are simple functions. But when we take sin log x, e raised to root x, these are composite functions. And remember this. Theorem. If y is differentiable function of u and u is differentiable function of x, then dy by dx is equal to dy by du into du by dx. Theorem. If y is differentiable function of u and u is differentiable function of x, then dy by dx equal to dy by du into du by dx. Now we have to prove this theorem. For that, write this step in delta form. So delta y by delta x, delta y by delta u, delta u by delta x. Take limit as delta x tends to 0 of both sides. Therefore, limit as delta x tends to 0 delta y by delta x is equal to limit delta x tends to 0 delta y by delta u. Limit as delta x tends to 0 delta u by delta x. If we see, then here is delta x, so limit exists. Here delta x, delta u limit does not exist. Delta x limit exists. Next step is this limit as it is. Here we have to change this limit into delta u. So limit delta u tends to 0 delta y by delta u, limit delta x tends to 0 delta u delta x. If we see now, then delta x, delta u, delta x. So limits at LHS and RHS. Limits at RHS and LHS exists. Limits at RHS and LHS exist. Delta x, delta u, delta x. So limits at RHS and LHS exists. Values of which are, value of this is dy by du. Value of this is du by dx. Value of this is dy by dx. Therefore, dy by dx is equal to dy by du into du by dx. Question: differentiate with respect to x y is equal to sin log x. So while taking derivative, take derivative of this first sin, that means cos log x, and multiply by derivative of log x, which is 1 upon x, is equal to product at numerator cos log x, product at denominator x. This is the answer.